Okay, moving into the second half of our notes on 11.2. So I'm calling this 11.2b, areas of regular polygons, and these ones are going to be a little bit uglier than the ones that we covered in 11.2a. You'll see why in a minute. So the first example I wanted to start you guys with is a pentagon, and if that side length that I gave you of 921 feet seems kind of random, well, it's because we always talk about what's a pentagon that you know out there in the real world, or a regular pentagon, and really the one example of that is the Pentagon. That's the building in Washington, D.C. that houses the Department of Defense and all the branches of the U.S. military. It's a massive building. It's actually the largest office building in the world, even though it's only, 4 or 5 stories tall. It's really, really wide and big, and it's got basements, like 17 layers or something like that. So anyway, we're going to start finding the area of this regular pentagon with a side length of 921 feet, which apparently is how big the actual pentagon is. I didn't know that. I had to Google it. Okay, so even though we haven't done a pentagon yet, we're going to handle this in the exact same way that we did squares, triangles, and hexagons in 11.2a. The first thing we're going to do is try to locate the center of our pentagon, which is probably roughly right about there, and then from there we're going to draw an apothem, which is a line segment that goes to the midpoint of one of the sides of the figure. So I'll show with tick marks that that's a midpoint, and the other very important thing is that the apothem is perpendicular to the side that you drew it to. So that's A, and we're going to need to find the length of that apothem in order to use our 1/2 PA formula that we were using again in 11.2a. And then the second thing we're going to do is draw a radius then that goes right next to that apothem, and that's going to be R. And so I was trying to be consistent in the way that I've done this here. By drawing the apothem and the radius, which we're going to do on every one of these problems, we form this little blue right triangle here. And coming up with the information about that triangle is the most important thing that we need to do here in order to be able to solve this problem. Now, in 11.2a, when we did triangles and when we did hexagons, when you drew this blue triangle, it always ended up being a 30-60-90. In squares, it was always a 45-45-90. So, unfortunately, sometimes people get in the habit of seeing 30-60-90s and assuming that that's what they're looking at. So, let's take a look at this problem, this triangle that we drew right here, guys, and let's see if we can figure out the measure of this angle. Now, the way I've been doing this lately is giving that a letter here, a Greek letter called alpha. All right, that angle right there. And the formula for finding that little angle right there, guys, is 180 divided by n. So if you don't have that formula written down in your notes, might be a good thing to know, and that's how you find this little angle right there. So in this problem, alpha is going to be 180 divided by 5. Excuse me, that's not what I meant to write. There you go. Divided by 5, because we're dealing with a pentagon, which has 5 sides to it. So grab your calculator there, and 180 divided by 5 is going to get you a 36-degree angle there for what I'm calling alpha. And right then, we can see something important. Even though that blue triangle kind of looked like a 30-60-90, it's not. We've got a 36-degree angle there instead. And that means that we are not going to be able to use special right triangles in order to figure out the measure of A. So how are we going to work on that? Well, let's get started. The first thing we're going to need to do is figure out the length of this piece here. And to do that, we're going to take a complete side length of 921 feet and cut that in half. And of course, it had to be difficult here. 921 is an odd number. So when we go to divide that by 2, we're going to get a decimal, not a terrible one, but 460.5 is what we get for the length of this little piece here on the bottom. And now we need to try to figure out what A is in order to be able to use our formula here. So to do that, everybody, what color am I going to go to now? How about a lovely shade of purple? All right, that's not what I meant. Okay. What we're going to have to do then, guys, is go back to basic trigonometry with that 36-degree angle. It's been a while since we've talked about it, but we're going to have to remember SOHCAHTOA as a way to find a missing side in a right triangle. So you're going to imagine that you are standing right here at that 36-degree angle. The side that we know, 460.5, is the opposite leg from where you're standing in the triangle. And A, the side that we need, is the adjacent leg. So which trig ratio uses opposite leg and adjacent leg? That's going to be tangent. So this is a tangent problem. We're going to write tangent, and then you always follow that up with the angle, which in this case is 36 degrees. And tangent of an angle is the opposite leg, in this case 460.5, divided by the adjacent leg, which is A. And this is the equation that we need to solve to get the length of the apothem. Now, there's three ways that a trigonometric equation can set up here. This, what we came up with right here, I wouldn't say is the best way, but I also wouldn't say it's the worst way. This is kind of the one in the middle. When the variable is on the bottom of the fraction, which is where our A is right now, the trick we learned back in chapter 9 here, guys, is to take this top left side and this bottom right side and simply trade their positions, trade places here. So that's going to get us A is equal to 460.5 stays in the numerator, but now we're dividing that by the tangent of 36 degrees. And I'm expecting an ugly number right here, so we're definitely going to need our calculator here. And let's type that in, 460.5. And then we're going to divide that by the tangent of 36, there we go, degrees. And I got 633.82. Now, guys, don't hit clear on your calculator right now. You'll see why in a minute. So 633.82, that's what we got actually right there for the length of the apothem. The other thing that we need, and I guess I probably should have talked about this a second ago, we're going to need perimeter as well, but I'm hoping that one isn't too hard for you at this point. To find perimeter of any regular polygon, since all the sides are the same, we're going to multiply the number of sides, which in this case is 5, times the length of each one of those sides, which again is 921. Yeah, I should have done that before I did this. Anyway, you guys go ahead and type that into your calculator. I did this problem earlier. I'm pretty sure that the answer there is 4605. Let me do this off to the side on my other calculator just to make sure I got that right. Yeah, 4605 is correct. So look at where we are right now, guys. We know our apothem, 633.82, and we know our perimeter, 4605, and that means that we're ready now to go to the formula for the area of any regular polygon. And that formula is 1/2 times its perimeter times its apothem. Let me just do this real quick. Okay, gotcha. So with that in mind, all right, let's go get them then. Step 2, fill in what you know. Area of a regular polygon here is 1/2 times a perimeter of 4605. Boy, that's big, guys. It's almost a mile to walk around the pentagon. That's a large building. And then we're going to multiply that by our apothem, which we had to round here. It's not exact, but rounded to 633.82. So now for step 3, let's go ahead and finish this thing up. Area of the regular polygon equals. And I want to show you guys an important way to do this that I'm going to be expecting you to do, and I'm going to be grading accordingly. These numbers, 1/2 and 4605, are exact. So we can just type them into our calculator, but this number here isn't exact. It's a rounded version. So the right way to do that is to use our calculator's features to get that answer as accurately as possible. Let me show you what I mean. So I'm going to go to my calculator, and without hitting clear, I'm going to type in the 1/2, probably easier just to put that in as a 0.5, multiplied by our perimeter, which is 4,605. And then when we go to multiply that by the apothem, what I want you guys to do on your multiviews is hit the up arrow one time and then hit enter. And what that will do is automatically copy and paste that ugly 633.82387744, and it'll do that both faster and more accurately than typing it in by hand. Now for me, if you guys are looking at my screen here, I've got this ANS button right underneath my 3. So when I hit this, that gives me the previous answer. And okay, what we have right here then, guys, is the most accurate possible way that we could come up with the answer to this problem. And I'm going to expect you guys to have this accurate to 2 decimal places. And if you you were to just manually type in 633.82, that wouldn't give you the answer as accurately as we want it. So this is messy here. I'm going to do this on my other calculator as well. So the 0.5 times the 4605, and then times, oh, I never came up with that other number here. Okay, so it's 1,459,379. That's 1,459,379. Make sure I have that right. And then two places, we're going to go to 0.47 for that one right there. Okay, all of our units here for perimeter, that was in feet. Apothem was in feet as well. Feet times feet is going to get us square feet. And that is the area, feet, there we go. That is the area, guys, of just one floor of the Pentagon. And as we said, it's 4 or 5 stories tall, but it's also got many, many layers of basement as well. So it is, in fact, the world's largest office building, as we said. So that is how we're going to find the area of a regular Pentagon. So the big takeaway for us, I think, in this problem here, guys, is the idea that unlike what we did in 11.2a with squares, triangles, and hexagons, now we're going to end up with an angle here when we find that alpha that isn't an angle in a special right triangle, and that meant that we were going to have to do basic trigonometry, SOHCAHTOA, in order to figure out the length of A in this case when we knew what x was. So it definitely gets a little bit tougher here in 11.2b, but if that concept made some sense to you, I think you're going to do okay with what's coming next. So the next example we're going to do here is going to be an octagon. And in that one, again, I would start off by asking you guys, do we see a regular octagon out there in the real world? And I'm hoping you guys remember, as many of you guys are sophomores and you're in driver's ed, that a stop sign, which you see multiple of every single day that you're out in the world, is a regular octagon as well. Now, I looked up how big a regular stop sign was, and it gave me a weird number for this piece down here, but we just did a problem where we were trying to find a regular polygon and we knew a side length. So I wanted this one to be a little bit different. So what I did is I kind of fibbed just a little bit right here and figured out, okay, gotcha. If the stop sign was the size that it told me that it was, that the apothem, which is what I've drawn for you here, is approximately, not exactly, 50 centimeters long. So that's the length of the apothem, more or less, in a stop sign, and that's what we've been given here. So the apothem was drawn. We're now going to go ahead and draw a radius right here next to that apothem, and that's going to be r. But we don't really need to find the length of r. That doesn't help us in our formula. What we do need, though, guys, is to come up with the length of x, which is this piece down here, and eventually finding x is going to lead us towards our perimeter. But before we do anything else, just like on the last problem, we have got to find alpha. And the formula for alpha is 180 over n. And in an octagon, our number of sides is 8. So 180 divided by 8 is going to get us a decimal, but not the worst decimal in the world. That's going to get us, oh, that's not what I meant to hit. Let's try it again. 180 divided by 8, yeah, is going to get us 22.5 degrees. So that's the measure of this little angle right here. I'm going to write it off to the side, 22.5 degrees right there. Okay, so in this triangle now, again, I would picture yourself standing right there at that alpha angle of 22.5. We know our apothem of 50, that is our adjacent leg, and x is the side that we need, that is going to be our opposite leg. So going back to SOHCAHTOA, what uses adjacent and opposite? Well, once again, guys, this is going to end up getting us a tangent problem here. So let me switch back to red for this one right here. And once again, we're setting up an equation now. It's the tangent of our angle, 22.5 degrees, that equals the opposite leg, which in this case is our variable, x, over the adjacent leg here, the apothem, which is 50. And this setup is actually the best possible case for a trig equation. Our variable is on the top. X is being divided by 50, so all we have to do now is multiply by 50 on both sides here. Those 50s will cancel, and this will give us our solution here for x. 50 times the tangent of 22.5. When you're starting a new problem, that seems like a great time to hit clear. So 50 times tangent of 22.5 5. And that's going to get us our side length right there, excuse me, x, half a side length of 20.71. So I'm going to write that down, 20.71, but we are not done yet, guys. We have found x. The next thing we need to do is figure out s, and s is the length of an entire side in this regular octagon. So how are we going to do that? We're going to take x and simply double it. So s is always going to be 2x, which in this case is 2 times 20.71. But again, remember that 20.71 isn't exact, it's rounded. So the best thing I can do on my calculator right now is simply hit times, oh, wait a minute. On your calculator, when you guys hit times, an ANS for last answer is going to pop up automatically. I actually have to hit answer right there and do times 2. But anyway, we should get the same answer now of 41.42, and that is the length of one side of this octagon. Why did we find that? Because we now need to find perimeter. The total number of sides here is 8, and the length of each side is the 41.42 that we just came up with. So again, for you guys, all you need to do here is hit times 8. For me, I've got to hit this answer button first, times 8. But we should all get the same value for the perimeter now, rounded, of 331.37. So let's write that down on paper, 331.37. And where are we right now, guys? We know our perimeter, that's right there, and we already knew our apothem right there. So that means we've got everything we need to go to the formula for the area of a regular polygon, which is 1/2 times perimeter times apothem. Let's keep writing it, let's keep saying it as much as we can. Step 2, fill in what you know. Area of the regular polygon is 1/2. The perimeter we said was 331.37, although that's rounded, and the apothem was exactly 50. So here we go. Let's put it all together in our calculators, but just like the last time, I got to be careful here. I don't want to manually type in that number. I'm going to use last answer when I get there. So here we go. We start off with the 1/2, which is 0.5, times, okay, and I'm going to hit answer on my calculator. You guys at this point would want to hit the up arrow and then hit enter on your TI, your multi-views. That'll do the same thing for you. And then we're going to multiply that by our apothem, which was 50, and that gives us an area for this stop sign of approximately 8284.27. So let's write that down, 8284.27. Everything here was measured in centimeters, and that means that our area is going to be square centimeters. All right, and that is how we would find the area of a regular octagon. So these two problems here side by side, guys, obviously are different. First one was a pentagon, second one was an octagon, but they certainly have some things in common. We started off finding alpha. That's not what I meant to do. Oh boy. We started off finding alpha first with 180 over n. We used alpha to set up a trig equation and find what was missing, and then we just had to make sure that we had both perimeter and apothem. That took some work for one of them, but we got it. And once we got perimeter and apothem, we were ready to go to the formula here of 1/2 PA. Okay, I've got two more examples for you. I'm going to do them in the order I have them written in here. This one is actually maybe the meanest of the four problems that I have for you. It's a nonagon, and if you forgot, you could certainly count right here that in a nonagon, the number of sides we are dealing with is going to be 9, starting with an N. That's kind of a clue there. But what makes this problem really nasty is that the piece of information that I gave you here is the radius of this figure. And that's difficult because the radius by itself isn't one of the things that we need to come up with the area of this polygon. We need perimeter and we need apothem. And that means that this problem is harder because we're going to have to use trig twice in order to figure out both of the pieces that we're missing. Okay, just like in every problem, if it's not already there for you, we're going to draw an apothem straight down to one side here, perpendicular to it. That's going to be A. And then this missing side down here on the bottom is going to be X. So we've got to figure out both A and X. A obviously is the apothem that we need, and X will help us find perimeter. And the radius is the one thing we were given. All right. So let's start this one the same way we did before. We've got to find alpha first. That's going to be 180 divided by your n value here of 9. And I was at least nice to you guys about this. 180 divides evenly by 9, and that's going to give us 20 degrees for the measure of alpha, this little angle right here. So imagine yourself standing at that angle right there, and we need to find both A and x. Let's do A first, everybody. So if we're going to find A, we're standing at this angle right here of 20 degrees, and we know the hypotenuse of this right triangle. That's our radius, and we need the apothem, which is the adjacent leg. So back to SOHCAHTOA, which one uses hypotenuse and adjacent? That is going to be cosine here. So for the first time today, we're dealing with a cosine equation. The cosine of our angle, 20 degrees, is equal to our adjacent leg, A, over our hypotenuse, which is 15. So what do we need to do now, guys? A is being divided by 15, so we're just going to multiply a 15 on both sides. Those are going to cancel, and we're going to get A equals. Let's clear out our calculators, and let's hit 15 cosine of 20 degrees, and that gets us an apothem of 14 point. Okay, if I were rounding that to two places, that would be 14.10. So 14.10. Although if we're doing this right, it really doesn't matter that much what we write down on our paper. Now I'm going to kind of circle that because apothem is really, really important here as one of the things we need to find. Okay, I'm going to switch to purple now. Now we're going to figure out what x was. So again, go back to your vantage point right here. X is now the opposite leg from where you're standing, and I still want to use 15, which is the hypotenuse. Opposite leg and hypotenuse, this is now a sine problem. Sine of 20 degrees is equal to the opposite leg, which is x, over the hypotenuse, which is still 15. And once more, we're just going to multiply both sides by 15 here. Those will cancel, and we're going to get x is equal to, and now we're going to type in 15 sine of 20 degrees. So 15 sine of 20, and I was expecting something a lot smaller. Yeah, and we got it, 5.13. Although remember, that's not exact, that's rounded. Okay, so we figured out what x was, and now from there, let's find s. A side length is always going to be 2 times whatever you just came up with for x. So 2 times 5.13. Again, you guys should just hit times 2 right now. I've got to hit this answer button. Times 2. Gotcha. And we get 10.26 for the length of one side. Okay, so then right next to that, let's find perimeter. How many sides do we have in this nonagon? That would be 9. And the length of each side was the 10.26 that we just came up with. So again, not typing in that number, I'm going to hit answer times 9, and our perimeter, as exact as we can get it here, is 92.35. 92.35, and there's the perimeter. So where are we right now, guys? We know the apothem, we know the perimeter. Those are the two things we need to go to our area formula. So area of a regular poly, 1/2 times perimeter times apothem. Step 2, fill in what you know. Area of that polygon is 1/2. The perimeter, which unfortunately is rounded, but I got to deal with it, is 92.35. And the apothem, again, this is approximate, is 14.10. Now, unfortunately, my calculator that I'm using doesn't let me do this the way that I'd like you guys to do it. So I'm going to talk you through it here as best I can. When we go to step 3 here, we're going to go to the calculator, and we are going to type in what we can do. 1/2 times perimeter times apothem. So I'll go with a 0.5 times. Now the perimeter, the rounded 92.35, is the last number I have right now in my calculator. So I'm going to hit answer. That's as good as I can do with that. And then times, now I need the apothem, everybody. And if you look here, the apothem I actually have listed in my calculator right now is that 14.10. Now what I can't do on this calculator is go back up and get that number. But what you guys can do is hit your up arrow multiple times until that long 14.09538931 is highlighted. So do that. until that 14 point whatever is highlighted in bold, and then hit enter. Now for me, what I can do to get that exact answer is go back to the expression I typed in to get it, 15 times the cosine of 20 degrees. So that's kind of another way of getting it too. If we've done this properly, then I think the most accurate answer we could possibly get here is what I have now, 650.82. So let me write that down, 650.82. Everything in this problem was being measured in inches, so that means that our area now is square inches. So on a problem like this, guys, where you had to do trig to find both the perimeter and the apothem, I'm going to have to give you guys a little bit of leeway in terms of the rounding right there. If you got something close to it, I think I'd give you full credit for it, but that's where we're at. Okay, so again, example 3 here was the hardest of the 3 that we've done, not because a nonagon is any harder than an octagon or a pentagon really, but because in this problem I gave you the length of the radius, and that meant that you had to do trig twice. There we go. You had to do trig twice in order to come up with both the apothem and the length of the perimeter right there. In the previous problems, one of those two things, in this case the apothem, and in this case x, was given to you already, so you only had to do trig once. But this is the worst case scenario where they gave you the radius. Okay, I've got one more example for you right here, but if you guys were kind of done at this point and you felt like you got it, I wouldn't mind if you guys shut the video off right now and said, okay, I think we're good. And if we were in class, I'd probably have you partner up with somebody and try this problem on your own. So that might not be a terrible idea to do either. But as it is now, I'm going to go ahead and walk through this last one. Hopefully it won't be too bad. We're dealing with a dodecagon, which is a weird shape right there. And just to save you from counting, in a dodecagon, the deca means 10. Do kind of sounds like dos, which is 2 in Spanish. So we end up with 10 and 2. This is a 12-sided figure. And the apothem has been drawn for us right here. That's 22 centimeters, which is definitely one of the things that we need. But the radius has not been drawn yet, so I'm going to draw that one right there, and that gives me this really skinny right triangle right here. All right, so I kind of moved away from highlighting those in the last couple examples, sorry. So if I highlight that, okay, that's the triangle that we're dealing with right now. Now this is the radius, but we really don't need it. What we need is to find x. So, just like in the previous 3 problems, we start off with our work to find alpha, which is 180 divided by n, 12 in this case. And that works out a little bit nicer than you might think. I'm pretty sure that's 15 degrees, but let me type that in and make sure. Yeah, 180 divided by 12 is 15. So you'll notice, guys, as the number of sides in your polygon keeps going up, this little alpha angle right here keeps getting smaller. This one is at 15 degrees. Okay, so again, you're standing right here, and this one should look familiar, guys. X is the opposite leg, and 22, which we know is the adjacent leg. Yet again, this is a tangent problem. So let me go to red here. The tangent of our alpha angle, 15 degrees, is the opposite leg, x, over the adjacent leg, the apothem, which is 22. We're going to multiply both sides by 22 now, and we should get a relatively small value for x. It certainly doesn't look very big. So we're going to type in, let's clear this out, 22, there we go, times the tangent of 15 degrees, and that gets us 5.89 for x. Okay, if x is 5.89, we need to find a side length, which is to multiply that number by 2. Always 5.89. There you go. So we're always multiplying by 2 to go from x to a side length. So again, I'm just going to hit answer times 2. You guys can skip the answer part there. 11.79 is the length of one side, and now we need perimeter. How many sides in a dodecagon? That's going to be 12. The length of each side is almost 12, 11.79. So this answer should be a little bit under 144, because that would be 12 squared. So that number times 12, here we go, is 141.48. 141.48. And there it is, guys. We just found our perimeter, and we already knew our apothem. So this really wasn't that bad. We're now ready to go to our formula. area of a regular poly, 1/2 perimeter times apothem, which in this case is going to be 1/2 times a rounded perimeter of 141.48. It's not exact, but the apothem is exactly 22 centimeters. So let's go to the calculator here. And again, we don't want to manually type in that rounded number there. We want to use last answer. So we're going to type in 0.5, there's your 1/2, times the rounded perimeter, which is our last answer. You guys are going to want to hit up, enter, and we're going to multiply that by our apothem, which had a length of 22. So we've got 1556.25 if we're rounding that to the nearest hundredth. 1556.25 units here were given to us in centimeters, so area is going to be square centimeters. And that is the area of that dodecagon. So I'm hoping you guys are looking at these scary problems right here and said, okay, they look bad and I definitely have to do some trig, but once we get the hang of it, it's not that bad. It doesn't take you that long, and hopefully you're feeling okay about these problems here. So we've gone through 4 of them: pentagon, octagon, nonagon, and dodecagon. That's certainly not all of them, but these are some of the nice ones where those alpha angles work out relatively nicely. And hopefully you're going to realize that the process is going to be exactly the same no matter what we're going to do next, and no matter how many sides that it has. All right, everybody, that is finally a wrap on our notes from 11.2. So let's dive into the homework on that, check your answers, and see how you're doing. Good luck, everybody.